Hello, guys. Welcome back to Math Zone African Motives. We are still on our integration, and this is an exam of April 2022. Yeah, that is April 2022, but it was actually written in June. This exam was written in June, actually, but still. All right. So after the introductions of the topics that we had of each, we're just gonna try to integrate everything. That's question to integrate y with respect to x. So whatever that we are integrating, these expressions of y here should be integrated with respect to x. So the first question, 2.1, that was going to be the integral of arc cot. So this is arc cot, the square root of x over the square root of x with respect to x. Okay. Let's think along the lines. What can we do? I said when we are given an arc for a certain inverse trigonometric functions for certain inverse, all right, arc cot, arc tan, arc sine, arc cos, we can use by parts. The question is, how can we use by parts while there is this square root of 3? Because by parts is supposed to be the integral of the two terms f of x by gx with respect to x, whereby this and this, they are actually different, or we can have this in form of g prime. All right, that is the format. We have got two different terms, which is a product of two terms. So here we do not have that. All right, remember you can take this on top, the square root. All right, remember the square root of x is the same as x to the exponent of a half. But since it is in the denominator, like that, 1 over this means it's going to be to the exponent of a negative. So here we are simply given two products. The product of x to the exponent of minus a half and arc cot the square root of x, which is same as x to the exponent of a half again. Because remember, I told you guys, there is no magic that you can work on a by parts that you have got a trigonometric function, which is an inverse, and an algebraic. Which method can we use? Which one can we use? Which one, guys? Can we talk? Substitution method was not going to work because you've got a square root and it's in the numerator. So whatever that, because at the end, we will still remain with the cot. And it is the one that we want to avoid to integrate direct. So substitution, forget about that one. It was not going to work direct. So now that we have this, we can now think of our formula by parts method. All right. So remember our formula. Also, you're given this in the formula sheet. It states that the first, the integral of f of x by g prime x dx is equal to f of x by gx minus the integral of f prime x, that this time gx dx, like this. All right. So as we can see from our formula, there is a need for us to have f of x. Okay. There is a need for us to determine what is our f of x, which is the part that we can be able to differentiate, avoiding by all means to integrate a cot because we can't integrate that direct. So we choose that to be our f of x because we can differentiate arc cot. All right. Remember, we can differentiate arc cot. So that will be our f of x. And the rest, which is g prime x dx, is what is remaining here, which is x to the exponent of minus half dx. So meaning to say g prime x dx is going to be what is remaining, x to the exponent of minus a half with respect to x. So this is gx dx here, g prime x dx, so that we integrate both sides to obtain gx. All right, let us just finish here. Here I'm going to talk about a lot, so let me leave it. I'm going to come back. Okay, from g prime, you integrate to obtain gx. So remember, integral, guys, we just have to add a 1, then divide by the new exponent. So if we add a 1, that will be x to the exponent of a half. All right, then we divide by the new exponent, which is a half. So 1 divided by a half is a 2. So that's 2x to the exponent of a half, which is same as the square root to square root of x. Remember, guys, to the exponent of half, it means what? The square root. So you can even leave it like that, all right? So that's your gx. Just leave it like that, or even like this, no problem, okay? So it's one and the same thing. So I'm just going to write n of this to square root of x. That is our gx from the integral. But f of x is supposed to give us what? The first derivative. So from f of x, we are supposed to differentiate this, the derivative of arc cot, the square root of x. So let us get back to our formula sheet. All right. So I want you on your formula sheet to check on your page 3 of the formula sheet. Right. Let's just hope those who write in 2030 or maybe 2020, 2027, there they are going to have the same formula sheet, or maybe it will be changed. All right, no problem. But if you check in your formula sheet, you are given on the derivatives, because this is the first derivative, all right? So under the derivatives, you will see under on page 3, you check under arc cot. You are given something of this nature under arc cot. They gave us arc cot and the derivatives under f of x as cot x, f of x like this, which is equal to minus, that is the derivative. So it means we are differentiating with respect to x, right? Which is going to give us minus the first derivative of f of x over f of x squared. So this is going to be f of x squared plus 1. Okay. This is the formula that we use for cot, for arc cot. So there's for arc tan, for arc sine, for arc cot, arc sec, arc cosec. You are given in the formula sheet. So do not worry about this. You break your head trying to memorize. But if you can know this, it's fine. Do that. Okay, it's fine. So this is what we have, arc cot square root of x. So meaning to say the square root of x is our f of x, and we said the square root of x is the same as to the exponent, x to the exponent of half. So it means we put derivative of arc cot x to the exponent of a half, that is the square root of x. So they are saying from this formula, if you differentiate a function of an inverse of arc cot like this, you are going to have minus the first derivative, which is minus the first derivative of f of x. Our f of x is the function that is affecting our cot, which is the function of x here, which is x to the exponent of a half, the square root of x. So we need its derivative on this formula. What is the derivative there? So the derivative of x squared, we drop the exponent, remember? Then we subtract 1 on our exponent, all right? So it's going to be minus half. Half minus 1, that's a minus half, over f of x squared. Guys, let us be together here. We want to be together. We want to be together here. We want to move together here. F of x squared plus 1. And this is our f of x, which is what? X to the exponent of a half squared like this, okay? Plus a 1. So let us just try to simplify. So if we simplify, this will be minus, all right? Let us simplify the top part first. So the top part, just leave it like that, all right, for now. Minus half x to the exponent of minus a half over x to the exponent of a half to the exponent of a 2. A half and a 2 multiplies, so that's half times 2, which is 1, so it's x. So it was going to be x plus 1. So this is what we have. And on this part, if we take a closer look, we can even write this in simplest form. How so? All right. Remember that to the this part here, this one. Okay, let me just try to write in simplest form. Negative half can be written as negative 1 over 2 like this. That's the negative half. Then x to the exponent of negative half, if we take it down, it is going to be x to the exponent of a half like that. But x to the exponent of a half means what? It means the square root of x. So it's going to be 1 over minus 1 over 2 square root of x into the bracket of x plus 1 like this. So this was supposed to be written like this, guys. All right. Minus 1 over 2 square root of x. All right. Divided to this x plus 1 that we see here. All right. We are dividing to this x plus 1. So I've got something of that nature like this. All right. So this is same like over 1. So it's going to be minus 1 over 2 square root of x times 1 over x plus 1. So if you multiply, you get back here. Yes, I think I'm going way to N3 and N3 stuff. Okay. No, anyways, this is what you're supposed to get if you simplify in simplest form. All right. I'm just gonna take the simplest form, this one, -1/2 square root of x. So this is our first derivative for arc cot the square root of what? The square root of x. All right. So let us bring our answer here because it was from arc cot -1/2 square root of x. So we got -1/2 square root of x into the bracket of, there was a bracket there. Yes, there was a bracket, x plus 1 into the bracket of x plus 1. I hope we understand where we are and how we ended up like this. Okay, this is where we are. This whole part is something that you're just supposed to do it aside, all right? This part you're just supposed to do it aside, but it's supposed to be there. Show all your calculations, okay? But this is the most important part on your calculations here. So since we said from our by parts formula, this is the formula that we are supposed to have. So meaning to say, from this whole part of our by parts, this one that we separated into two, and we obtained these calculations from each, we are going to substitute into the formula. Whatever that we have or that we are integrating is supposed to be equal to f of x, all right, times gx. So you're going to have f of x times gx. Our f of x is arc cot. So this will be arc cot the square root of x times gx. Our gx, which is 2 square root of x. So this will be 2 square root of x minus the integral of the first derivative with respect to x of this, which is this one that we got. So we got, let me just try to increase this because we've got a lot of things here. So we've got -1/2 square root of x into the bracket of x plus 1 like this times gx, and our gx we got 2 square root of x, all right, dx. So this is where we are. Whatever that happens later on, it's up to that equation. It's up to that question. Our part was to apply the by parts formula, and we applied it. This is what we have. So let's simplify and see what's going to happen later on, because we are supposed to simplify further and integrate where possible. So this multiplied to 2 square root of x is the same as we can just write 2 square root of x times arc cot, the square root of x. Okay, this is where we are. Then we can take the negative and the negative out. All right, negative multiplies, it gives us a positive. So that will be positive. All right, inside of the integral, we've taken this negative and negative, remember? So inside of the integral, this is same as over 1. So if we check properly, there's something that is happening here. The 2 square root of x and the 2 square root of x can cancel, meaning to say you'll be left with 1 over x plus 1. So we are left with the integral of 1 over x plus 1 like this with respect to x. So this is what you have. You now have to integrate this. So it depends. Maybe sometimes there you obtain a quadratic. I don't know what's going to happen here. It depends. So it's not like always you're going to have something like this. No. You can have maybe 1 over x squared. You have to figure out how to integrate that. Maybe it's another, you can have another again, a condition whereby maybe you are working with another by parts. If we don't know what's going to happen there, it depends with the question. So here, this is what we have. And how do we integrate 1 over x plus 1? Remember this from our ln. So this will be 2 square root of x arc cot, the square root of x plus, remember this gives us a ln, so it's going to be ln x plus 1. All right, we divide by the derivative of this x, but the derivative of x is 1, so it does not affect, plus the constant of integration. So that's it. Is there anything that we can do? There's nothing that we cannot do here. Everything is in simplest form. We just have to leave it like that. So that is the whole procedure that you were supposed to have in this integral of arc cot square root of x over the square root of x. So guys, you have to be careful in your simplification. How do you expand in the first place? All right, what is it that you're thinking of? Because if you know your syllabus, also you can even tell, say, I know this cannot, we cannot think of applying trigonometric here. Which trigonometric is that? And also in our syllabus, we do not have algebraic substitution on its own. Algebraic substitution was in N5. Algebraic substitution, I'm not saying it's not there. It's there, but you're not going to find a question direct which requires you to apply a substitution method. Maybe we are given 2x. Here we are given maybe the cos of this is x to the exponent of 3 plus maybe 1 or maybe 2x, whatever, where you can even apply or try by all means to apply your substitution, or maybe you've got the integral of x cubed plus 2x plus 1 like this to the exponent of 3 dx. You are not going to have a question like that which requires you to apply a direct substitution. You find substitution inside of another question as you are working another. That's where you find it. I'm not saying it's not there. So by just looking this, substitution is out, totally out. So we can't think of the trigonometric solving this. It's impossible. So the only part that is there is by parts. So now it's for you, how can we operate under by parts? How can we separate this to give us exactly the expression of by parts? We can't think of completing the square. Can we complete a square here? No. Because in our syllabus, we know that we're going to have by parts, all right? Then we've got the part of the trig. Then we've got the part of the quadratic, which we use, completing of the square method, completing of the square method. That is the only part that we have. By parts, trig, and completing of the square. So meaning to say, if this is not trig, if this is not completing of the square, therefore it's going to be by parts. All right. So it is the same thing that we are going to do here on question number 2.2. Can we apply by parts here? No. Is it a trig? No. So what are we left with? We are just left with completing of the square. That is what we have in our syllabus. Those two, those three. So here we have to think of completing of the square method. Can we complete the square on this one? Yes, we can. All right, so let us write this. 2.2, the integral of 1 over the square root of 3x squared, all right, plus 5x plus 1. Plus 5x plus 1 with respect to x. Whatever that we are integrating is supposed to be done with respect to x. So remember, I talked about the completing of the square method since our N3 and so forth and so forth. And we've got different ways of completing the square, in this case, from our quadratic. So you take the quadratic, which is, all right, so complete the square. So we are going to take the quadratic expression that we are given here, which is given as 3x squared plus 5x plus 1. How do we complete the square? Using the traditional method, we have to make sure that the coefficient of x squared is a 1, right? So we factor out the 3 so that it gives us a 1. 3 divided by 3, we get x squared. So it's 5 divided by 3. 5 divided by 3, it still remains as what? As 5 over 3x. 1 divided by 3 still remains as what? As 1 over 3. So this is what you do. Making sure that the coefficient of x squared is a 1. What is affecting x squared here is 1. After that, you have to determine half of the coefficient of x and square it. This is the coefficient of x. So you determine the half of that, then you square that half. So this is half of 5 over 3. You square it. Half of 5 over 3 is going to be 5 over 6. 1 times 5 is 5. 2 times 3, which is 6. So it's 5 over 6 squared. So this square, don't simplify. Yes, you can simplify, it's fine, but just leave it like that. All right. So you take the square, add the square, and also you have to subtract this square so that you neutralize your question to the original format that it had before. So this is going to be x squared plus 5 over 3. We have to complete this quadratic here to be a perfect square. So we add the square that we have, which is 5 over 6. So that will be 5 over 6 squared. All right. Then we have what a constant that was already there. We just write as it is. So it's going to be plus a constant of 1 over 3. Then we subtract that square that we added. So we are going to subtract 5 over 6 squared like this. All right. So that is it, guys. So now we can factorize on our quadratic expression. As we can see here, we've got a quadratic from x squared here up to 5 over 6 squared. It's a perfect square. It's a quadratic expression, but being a perfect square. So how do you factorize this type of an expression? I said you take the first term and the last term that are being raised to the exponent of 2, x and what? And 5 over 6. The ones that are being raised to the exponent of 2, x and what? 5 over 6. So it's going to be 3 into, so you're going to open the bracket, x plus 5 over 6 squared. So you square this. You have factorized the whole of this quadratic expression. So what is left is this expression to be combined together. All right, so there we can just use our calculator for the simplification. Let's try and see. That's 1 over 3. Sorry, 1 over 3. Then minus 5 over 6 squared. So you're going to subtract 5 over 6 squared. So if we square this, that will be negative 13 over 36. So you're going to obtain negative 13 over 36 like this. All right. So expand by 3 inside. What are you going to have is 3 times this bracket, which is being raised to the exponent of 2. So it will be 3 into the bracket of x plus 5 over 6 squared. It has no access to be multiplied inside of the bracket. Then it multiplies minus 13 over 3. So the minus 13 over 3 here multiplied by the 3 outside of the bracket. Remember, there is a 3 here outside of the bracket. So if multiplied by 3, we are going to get negative 13 over 12. So this is negative 13 over 12. So we have multiplied by the 3 that was outside of the bracket each. So this is what we have. We have completed the square. But like I said also, we can use the formula in order for you to complete the square. You can also choose or opt for the formula. What is the formula states? All right, we also have this formula since our N3. The formula states that if I am given a quadratic expression of ax squared plus bx plus c, this is equivalent to, when I complete the square, I'm going to have this as 4ac minus b squared over 4a plus a into x plus b over 2a, all right, squared. So this is how you play around with the formula. So meaning to say, from our quadratic expression, what was our quadratic? The quadratic expression is this one, 3x squared plus 5x plus 1. All right, so we were given 3x squared, right? This was given as 3x squared plus 5x plus 1. So it means our a in this case is 3, our b, which is the coefficient of x, is 5, and our c, which is the constant, it's a 1. So you just have to substitute this. As long as you know the formula, you just have to substitute. So it's either way, you choose the traditional method or you choose the formula. All right, so here you're just going to substitute. So it means this whole part of 3x squared. All right, let me just write this way. 3x squared plus 5x plus 1 was going to be 4a. So it's going to be 4 times a. Our a is 3 times c, our c, which is 1, minus b squared, our b is 5. So it's going to be 5 squared. Everything over 4 times a, our a, which is 3, like this, okay? Plus a, which is 3. So that is a into the bracket of x plus b over a, our b is 5. So it's b over 2a, which is 2 times a, our a, which is 3, like this. Then we square everything. So you substitute the values that represent the letters that you're given there. Then from there, we can simplify what can be simplified on our calculator. Put a fraction, that will be 4 times 3 times 1. All right, so that's 4. That's 1, guys, does not affect. All right, anyways, let's write minus 5 squared. So you're going to subtract 5 squared over 4 times 3, which is 12. 4 times 3 is 12, okay? That's minus 13 over 12. So this will be minus 13 over 12 plus, this will be 3 into the bracket of x plus, we simplify 5 over 2 times 3 is 6. So this one is just going to be 5 over 6 squared. Okay, so that's how we can have this done. And as you can see, it is the same answer just like the previous one that we got here. Same presentation. All that here we can just start with a positive. This one, so it's going to be 3 into the bracket of x plus 5 over 6 squared. All right, plus 5 over 6 squared minus 13 over 12. So it's exactly what we got from the traditional method And from the formula, we have got the same thing. So with the completed part here that we have completed the square, which is either way, whatever that you choose, whether to work from the formula. So this was from the formula. You are using the formula of completing of the square, this one. So you have to know this because so far we are not having this formula in our formula sheet. It was just for N2, N3, yeah, N3. So far for N6, we do not have this formula in our formula sheet yet. But we just hope as time goes on, we shall have this formula. It can help us just that we have to just substitute everything, all right? But so far we do not have that. So it's up to you to choose which one is best for you. Now that you have completed the square, we are going to take this. You have completed the square, all right? So you take what you have completed here into the quotient. So that is here, we are going to have this as the integral of 1 over the square root of this whole part of 3x squared plus 5x plus 1. This whole part is the one that we have been simplifying here and is the one that gave us this part here. So we're going to write what we got. So this is, let me just try to increase. I'm just going to try to increase this so that we can accommodate everything. So this will be the integral of 1 over, in this case. So we've got the square root of, so you're going to have 3 into x plus 5 over 6 squared. So this is x plus 5 over 6 squared, like this, minus 13 over 12. So this is minus 13 over 12 with respect to x. That is what the completing of the square only helped us to do. To find this, only to have this. After that, you are supposed to figure out how to integrate because the question is on integration. All right? Our question is on integration. So how do we integrate this? All right, so always on a condition that you are working with the completing of the square method, you are going back on your formula sheet on page number 4. I'm going to explain this. This is the page that we have here on page number 4. So on your formula sheet on page number 4, this one, you are going to see these integrals that are there that are listed from this one, from this integral here, down up to the last one here, up to the last one, which is here. These integrals, these are the ones that you use to answer a question under the completing of the square. You form something that is going to be meshed with one of these integrals that are presented on the left-hand side. So these are the integrals that are there on the left-hand side. And these are the presentations of how our answers are supposed to be presented as. So if we check on our question, we are now at a stage like this. It was like this, the integral of 1 over the square root of, remember, it was the square root of 3 into x plus 5 into x plus 5 over 6 squared, like this, minus 13 over 12. Remember, this is the stage where we are with respect to x. So we are supposed to pick one of these which is in this format. Which one is in this format? 1 over the square root of this format. All right, let's check the first one. Dx is the same, 1 times dx is dx, so we've got the same format, but here it's the square root of a squared minus. All right, so this one is not exactly in this format, unless if we are to make this to be the subject, we factor out a negative, but where are we going to take the negative? Because we can't determine the square root of a negative. So this one is difficult for us to even make it look this way. So this one is totally out. We move on to the second one. We do not have a square root. It's also a positive here. So this one is totally out. It is not of this same format. The second one, it's under the square root, yes, but we do not 1 over, and even the format is just similar to this one. So this one is totally out again. Dx over a squared, this one, we do not have a square root. So this one is totally out. Okay. We move on to this, the square root of this, we do not have 1 over, so this one is totally out also. We are left with this one, dx over the square root of b squared x squared plus or minus a squared. This is exactly what we have, the square root of. Remember I said 1 times dx is the same as dx. So this is the best because we can have this number here can be written as b squared. already there's a part of x squared. Then here they are saying plus or minus, meaning to say even if it is a minus, it can work. And this number can be written as a number to the exponent of 2. So the last one is the best formula for us to use. All right, so we're going to take this formula so that we'll be able to integrate this. All right, so I'm just going to try to rewrite that formula again. Remember, our formula is stating that the integral of dx over the square root of, it is written like this, the square root of b squared x squared plus or minus a squared is equal to, all right, I'm just going to take that formula as it was from the last formula I showed you. So they're saying it is equal to 1 over b, all right, the ln of bx. So this will be ln of bx plus the square root of b squared. And I think I worked with this formula in another class. So this is going to be b squared x squared plus or minus a squared, plus or minus a squared, like this, plus the constant of integration. That's how we integrate something of this nature. So we said we can be able to write this. That's why we choose this, because that is the only formula that is near at end. We can write this in this form. How can we write this in this format? This is just the integral of, remember 1 times dx is the same as this dx that we see. So it's the same as we've got dx there over the square root of 3. How can we write 3 as a number to the exponent of 2? So 3 is same as the square root of 3 to the exponent of 2. We haven't changed anything. We just want to write as a number to the exponent of 2. So it is the same as what? The square root of 3 squared. All right. Then we have got x plus 5, which is already to the exponent of 2. So here there's nothing that we are changing. X plus 5 over 6 squared is the one that represents what? Our x squared. Plus or minus, here we've got a minus, so we're just going to write minus. So how do we write the 13 over 12? How do we write this 13 over 12 as a number under the square root? How do we write it like as a number under the square root? So it's going to be square root of 13 over 12 squared. As a number squared, I mean as a number squared. So it's going to be under the square root, then we square it. If you square this square root of 13, it gives us 13 over, just like what we did on 3. Is the same as square root of 3 squared. What we just want to see here is properly see our b squared, which is from this. This represents our b, the square root of x. X is represented by the whole of this part of x plus 6. It represents your x squared. The whole of this part of the square root of 12 over 13 represents our a. So wherever there's a, we put this. So the question is that if we can write it in this format, what is going to be the answer? The answer is going to be given as 1 over b. So it's 1 over b. What is b? B represents the square root of 3. So it's 1 over the square root of 3. Okay? Ln bx. So it's ln bx, which is our b square root of 3. So it's going to be square root of 3 for b. Then what represents x? X is represented by the whole of this. Take note there, you don't write x as it, you take as this part as the bracket. That is the one that represents your x squared. So it's x plus 6. So it's going to be into x plus 5 over 6, like this. X plus 5 over 6. All right, plus the square root of b squared, x squared, this. If you check this here and this here are the same. So if they are the same, this is exactly what we have here. And exactly what we have here is this part here that we have. So we are just going to rewrite this square root as it was before. We are not simplifying anything there. It's a rewrite. They are just rewriting as it was before. So we are just taking the square root. But instead of you writing this one, which is not simplified, where the square root of this, write the one that is what? Simplified. So it's going to be square root of 3 into x plus 5 over 6. So this is x plus 5 over 6 here. So it's going to be x plus 5 over 6 squared. All right. Minus 13 over 12. So that's minus 13 over 12 like this. All right, so that's it. We have taken out everything. So that's it here, plus the constant of what? Of integration. So let me just remove that part that we were completing our square here. So you're going to add the constant of integration. We are done. So that's how we simplify this. Is there any other part that we can simplify further? There's nothing here. You can even leave it like that. So the x there represents the part of x plus 5, as it is the expression that represents your what? Your x plus 5, where there is x, all right? Where there is x. So it's going to square root of 3 into x plus 5, and this will be 3 into x plus 5 squared minus 3 like that, all right? So this is how we play around with this type of equation, as you can see, all right? So you apply your completing of the square. After completing of the square, you have to choose the best formula. There's only one that is going to suit your question. There's only one that is going to be applicable for your integrals from those formulas that I showed you. It's only one. All right, let's check the other part. 2.3. All right, so now 2.3. So 2.3 is a trig. So this one is a trig. We just have to figure out how to integrate that trig, as we know all the trig that we have in our syllabus. So which format is this one? The integral of cos to the exponent of 5 of 2 pi x. So this is 2 pi x. Then we've got the sine to the exponent of 3 of 2 pi x again with respect to x. All right, what type of an integral is this? This is the integral that we have under our trigonometric. Okay, under trigonometry, we have got a condition or a combination that can happen of a sine and a cos, or a cos and a sine, raised to different exponents, or they can be raised to the same exponents. That part does not matter, but it is of this format. I'm just going to rewrite this. It is the format of, this is the format that we have in this manner. The integral of a cos. So it can be of a cos, or you can write in terms of a sine. It does not matter how you want to have it written. All right, so I'm just going to write in terms of a sine. Since I introduced, on my introduction, I introduced using sine. So I'm just going to use sine so that I do not confuse you. To the exponent of m by cos ax to the exponent of n dx, like this. Whenever you are given this format, there are two things that you need to figure out. In fact, there are two things that you need to figure out. One, are you working with odd exponents? The powers that you're given there, are they odd? Both here are odd. So when you are dealing with both odd, you split, all right? You split the one with the smaller exponent. You split the one with the smaller exponent, or the smaller power. That is on a condition when both are having what? Odd exponents. So yeah, we are talking about when the exponents or the powers are odd. But on a condition that one of the powers is odd and one is even, you expand the one with an odd power. Whether it is the smaller one, whether it's the bigger, you expand the one with an odd power on a condition of odd and even. But here we're just given both odd, so you expand the smaller one. How do we expand the smaller one? We expand this from the identities, or from the identity of sine and cos. Remember, we said we're going to use this identity, sine squared ax plus cos squared ax is equal to 1. So since the smaller exponent is affected on what? On sine, we have to think of making sine the subject. Sine squared ax is going to be equal to 1 minus cos squared ax. So what it means is that as we are to split this, we are supposed to split this bearing in mind that I'm supposed to obtain what? A sine squared, so that I can replace with the equivalent identity for sine squared. That's what I'm trying to say here. So we are going to split this as the integral of cos to the exponent of 5 2 pi x. Then a sine is going to be given as, we want a sine squared. That's the major thing that we want. So it is going to be sine squared 2 pi x. But in order for us to remain with this sign to the exponent of 3, we are supposed to multiply by what? By sine 2 pi x. So if we multiply this, we get back this, you get back to the original question. So that we have introduced the sine squared. The purpose of splitting this is so that we substitute with the equivalent identity for sine squared, which is the equivalent identity for sine squared is what? 1 minus cos squared. So this here represents a single term. These two is just a single term. So you can even combine them together like this. Cos to the exponent of 5 or 2 pi x sine 2 pi x like that. It does not affect like this, 2 pi x. All right. Then this sine squared, this one that I'm indicating, it is going to be 1 minus cos squared. So it's going to be 1 minus, if this is ax, this is also ax. So this does not change. It is going to be 2 pi x with respect to x. Okay. At this stage, we are supposed to think of integrating by introducing the substitution. But there is, I said, whenever there is a 1 like this, substitution can be limited and it can be difficult. So in that manner, expand your integrals because this is a bracket. So you expand this into here. So it is going to be the integral of cos to the exponent of 5 2 pi x sine 2 pi x. All right, we have multiplied 2 to 1. Since we are integrating with respect to x. All right, we do the same thing. This multiplies here, but there's a negative there. So it is going to be minus the integral of, we multiply these together. So a cos and a cos, when multiplied, we add the exponents. So it is going to be 5 plus 2, which is 7. So it's going to be cos to the exponent of 7 of 2 pi x. Then sine is just going to remain as it is, which is sine 2 pi x with respect to x like that. So this is where we are, and we are supposed to integrate this part that we are at our last stage. And if we cross-examine, you see that there's a sine 2 pi x here, which is the same as the sine 2 pi x here. They're the same. A cos and a cos, even though they have different exponents. So we can think of substituting so that we eliminate or we get rid of this sine 2 pi x, sine 2 pi x. So how can we get rid of that? We have to make u to be cos 2 pi x. All right. So in this case, using substitution method. So we are now on the substitution. That is what I was saying before. You do not use substitution method on its own. You find it on another topic, on another part as you are integrating. So using substitution method, you're going to let our u to be equal to cos 2 pi x. So that will be cos 2 pi x. Find the derivative of u with respect to x. Remember, cos changes to a negative sign, and we multiply by the derivative of our f of x, which is going to be 2 pi. The constant, you take it outside, so it's going to be minus 2 pi sine 2 pi x. All right, so this is the derivative of what? Of u with respect to x, and we are supposed to make dx the subject. So if we make dx the subject, it's going to be du over negative 2 pi sine 2 pi x. So most of you are saying, I'm not supposed to take this negative up. You can take the negative up and ignore this one like this. So it will be minus du over 2 pi sine. It's one and the same, or you can just leave the negative in the denominator as it is like that. It's one and the same thing. So I'm just going to leave it like that so that do not confuse each other. So this is dx. So using substitution, remember from your N5, once you find dx, you are supposed to substitute back your dx in this part here. So we were supposed to integrate. Okay, let me just do it stage by stage so that we'll be together. So we are supposed to have cos, which is represented by what? By u. So that will be u to the exponent of 5 by sine 2 pi. So this will be sine 2 pi x dx. And our dx is now represented with what? With the du over negative 2 pi sine 2 pi x, okay? Minus the integral of cos. Again, wherever we see a cos, we are going to substitute with a u. So that will be u to the exponent of 7 sine 2 pi x, which is going to be sine 2 pi x by dx. And this is our dx, which is du over negative 2 pi sine 2 pi x, sine 2 pi x. So there was no need for us to even substitute like this, because you can see that the sine 2 pi x and this will cancel. So there's no need for you to represent this. You just have to take the 1 over this out of the integral, and you remain with the u, and that was the stage that you're supposed to have. But just for the sake of revision, guys, all right, this is what's going to happen. The sine 2 pi x and the sine 2 pi x will cancel. So we can take 1 over minus 2 pi out of the integral. So if we take this, we're going to have negative 1 over 2 pi. Instead of writing 1 over minus 2 pi, you can write minus. Instead of writing 1 over minus 2 pi, you can just write as negative 1 over 2 pi. It's a constant. Out of the integral, we remain with the u to the exponent of 5 with respect to u. All right, minus. We do the same thing, but if we are to do this here, we're going to cancel the sign and the sign, sine 2 pi x, sine 2 pi x. So if we are to take the 1 over minus 2 pi out of the integral here, there's already a negative. So it's a negative, and this negative, it gives us what? A positive. So this one is going to be a positive. We take 1 over 2 pi outside. Then we are left with a u, which is u to the exponent of 7 with respect to u. So there we can be able to integrate, since we are left with a u and it is with respect to u. So this will be minus 1 over 2 pi. We integrate u to the exponent of 5, we add 1. So that will be u to the exponent of 6 over the new exponent, which is 6, plus 1 over 2 pi. We integrate u to the exponent of 7. We add 1. So it will be u to the exponent of 8 over 8 plus the constant of integration. So we have to substitute what we are given. And we have, in this case, the u representing what? Cos 2 pi x. So if we multiply, this was going to be negative u to the exponent of 6, of which negative u to the exponent, our u is cos. So it's going to be negative cos to the exponent of 6 of 2 pi x, like this. Everything over 2 pi times 6, that will be 12 pi. You can just multiply together, guys. Let's just multiply 12 pi. All right, we do the same thing here, plus, if we multiply the numerator to the numerator, if we want that, u is given as cos, so that will be cos to the exponent of 8 of 2 pi x. All right, everything over 2 pi times 8, 2 times 8, that's 16. So it's going to be 16 pi. Okay, plus the constant of integration. So that is how we could have simplified our answer up to this stage. There's nothing that you're going to do. We are done with the integration. We've integrated everything. So this is your trigonometry, guys. That's how you play around with your trigonometry. So you need to know the conditions of each. You're supposed to know each condition of the condition of each trig. How do you work with a sine? The conditions of a sine and a cos. If there is a product of a sine and a cos, how do I work with a tan and a cot? Those are the ones in your syllabus. You're done. So you see, it's very, very easy. Very, very easy. You just have to know each part. So make sure that you watch the introductions on each and every part so that you understand what we are talking about. Then the other part, it's lean squared. All right, lean squared. Why is it want to, okay, no problem. Lean squared. So this is what we have here, 2.4. The integral of lean squared x with respect to x. We cannot think of the trig. There's no way. We cannot think of completing the square. So what are we left with? By parts. Remember, those are the only three in your syllabus. By parts, completing of the square, and those trig. So it cannot be, you cannot think of a trig. Which trig can represent lean? There's no trig. Completing of the square is totally out. So we're just left with by parts. But how can we make it to be a by parts? That is the question. How can we make this to be a by parts if it is like that? Okay. Let's think about this. Remember, in our N5, we just said a lean. In our N5, it was like this, lean x dx. Now they square it. Guys, you see these people. So we introduced a 1, if you still remember. So it is going to be the same thing, the integral of 1 times the lean squared x. Why introducing 1? So that we can have a product of 2 terms. Remember, by parts, it's applied when we have got a product of 2 terms. That's why you see the formula is given as the integral of f of x by g prime x dx, like this. The product of 2 terms is equal to f of x by gx minus the integral of f prime x gx dx, like this. This is our formula. So the condition that there's a product of 2 terms here, so it means we need 2 terms. So 1 cannot be our f of x, because if 1 becomes f of x, look what was going to happen. If you differentiate this, we get a 0. That will be the first derivative. So meaning to say we no longer have anything here. So there's nothing there. So 1 cannot be that, all right? 1 cannot, even here it's a 0, so there's nothing that you are calculating. So meaning to say your f of x is going to be the ln. You're going to take ln. And I said whenever you work with a function, whether it's a trig and this, a ln is best to use as your f of x, all right? So we are going to let our f of x to be the ln, which is ln squared x, all right? Then that means g prime x dx is the remaining part. What is remaining? It's 1 and dx. So that will be 1 dx. Integrate both sides with respect to x. We are going to get gx here. Then we integrate 1 with respect to x. It gives us what? X. But on this side, we are supposed to have the first derivative. I just left it so that we can properly find our first derivative here. So if we are to find the first derivative here of f of x, all right, what is the answer? How do you differentiate a ln? And this is different from a condition like we've got a ln squared like this is different from ln x squared. It's different. A ln squared like this, it means we are multiplying 2 of them. So it's like there's another ln like this. So you can only write it in this way, ln x to the exponent of 2, not ln x squared like this. This will be wrong, all right? So if it means we have got ln here, if it means here, we have got ln x to the exponent of 2. How do we differentiate? We are back to a function of a function by side. From our mathematics N5, we have got these derivatives that we do by side. Straightforward. You differentiate the outer bracket, all right? You drop the exponent, it's going to be 2 ln x, we subtract 1, all right? So we subtract 1 on the exponent, 2 minus 1 is a 1, so it's just going to be 1, times, you differentiate what is inside. Remember your functional function inside of the bracket. If we differentiate ln, it gives us 1 over x. So it means this whole part of the first derivative with respect to x was going to be 2 times 1 over x, which is 2 over x, into ln of x. This is what we have. Let's leave it like that. So we have first derivative, we have got gx, f of x. So we need to substitute into the formula. So the formula states that for any integral that we are going to have, as long by parts can be applied, we are going to have this as our answer to that by parts, which is f of x. Our f of x, we said, is what? It's ln squared. So this is going to be ln squared x times gx. Our gx is x. So that's x minus the integral of the first derivative with respect to x, and our first derivative with respect to x is this one that we got here, which is 2 over x by ln of x times gx dx. Our gx is x, so this will be x dx like this. So we are back again, this and this cancels, all right, x and x. So we are going to be left with in this case, it's going to be x is ln squared x times x is just going to be x ln squared x minus, we can take the 2 out of the integral, so it's going to be minus 2 the integral of ln x dx like this. Okay, so the question is, we are now at a stage where we have got a ln x here, where we are supposed to integrate a ln x. Do we have the integral of a ln x? That is the question. All right. So like I was saying, in our N5, we had this we had this by parts. So instead of us applying by parts again, we have this in our formula sheet, guys. All right. So you can use yes by parts, or we can take the formula into consideration. If you check from your formula sheet under derivatives on page number 2, and we are dealing with a ln. All right. Ln AX, as long it is in the form of ln AX. If you check there is ln AX like that. So they are saying the integral of ln AX is going to give us x ln AX minus x plus c. So if this is the case, therefore, if we integrate a ln AX, this is a 1. So it means where there is a, we're just going to put a 1. This is a 1, this is a 1. So that is the case. So meaning to say this was going to give us x ln squared x minus 2 times the integral of ln x, which is the one that we get here, which is going to be x ln AX, our a, there is a 1. So it's just 1x, which is just x. So it is going to be x ln x minus x, our x as it is, which is x like that. Then we add the constant of integration. There's no need for us to apply by parts. Yes, we can do that, but there's no need for you to apply because you have this in your formula sheet, all right? So you can just take it direct as it is. So this will be x ln squared x multiplied by 2. So there'll be minus 2x ln of x minus 2 and x, that will be a positive 2x plus the constant of integration, or you can even leave it at that stage with the brackets like that. So that is how we're supposed to integrate this, okay, by just using our by parts method. All right, I hope we are together on this one. I hope we are together. We just have to write in a way that we can be able to apply our by parts. Once we have that format, then we apply our by parts as usual. But where there's a need for us to use the formula, if it is there direct from your formula, there's no need for you to keep on doing by parts. You just write the answer direct as it is. Yes, you can do that. You write your by parts, which is fine. All right, let's check the other question, 2.5. So on 2.5, again, it is to integrate, and we're asked to integrate. This is tan squared. All right, so this is 2.5. The integral of tan squared into 3 minus 2x like this with respect to x. All right, so how do we integrate a tan? How do we integrate a tan? That is the question. How do we integrate a tan? So you can choose here. There are two ways that you can choose to work with. A tan can be integrated direct from our formula sheet. We have that condition, but it is a condition now. Let me write it down for you. It is a condition when it is a tan squared like this. When it is a tan squared AX. So what does it mean here when it is tan squared? It means we are just dealing with a single term and it's a linear. So yes, it's a tan squared, but this one is not it's 3 minus x. If it was tan squared f of x, we were going to use, because they are saying any f of x can be used, but they are specifically mentioning that it must be in the form of ax, not to be an expression of this nature. So meaning to say, in order for us to use it, we can introduce this to be our u, so that we can now talk about this, because the integral of tan squared ax can be integrated. It's a linear and it's a single term. So if we make this to be a single term, that means we can be able to apply it. And that is only if this is a single term. And which single term can we think about? We can think of substitution method. So we can let our u to be equal to 3 minus 2x. Okay, so I want you to see what's going to happen. Du dx in this case, if we differentiate 3, that's a 0. Minus 2x, it gives us minus 2. We make dx the subject. This is du over dx. So we make dx the subject. So it was going to give us du over minus 2 if we do that. So what it means is that we're going to substitute here. So it was going to be the integral of tan squared, because we say this is our u, not tan, but the part of the bracket here. So it is going to be tan squared u in this case. This part is now u. With respect to x, our x, which is now minus du or du over 2, or you can write it as minus du over 2, or like this. So meaning to say we can take out 1 over minus 2 out of the integral, and this will be negative 1 over 2. The integral of tan squared u with respect to u. And at this stage, guys, we can use that integral that I was talking about. So this, let me just remove it. We can use that integral for tan because it's now a single term. And it states that on page number 3 of your formula sheet, you'll see tan squared there. It states that the integral of tan squared ax dx is equal to 1 over a. So it's 1 over a tan ax. So it's going to be tan ax here, tan ax minus x plus c. This is how we integrate a tan squared. So there we have got a tan squared u, and it's a single term. So this is going to give us minus 1 over 2. We integrate our tan squared. So it's going to be 1 over a. A is the coefficient of this. What is the number there? It's a 1. So 1 over 1, guys, is just a 1. All right. So you're going to have tan ax, which is tan u in this case. So this will be tan u minus x. Our x, we're talking about u. So this part of ax is the part of u. So it's going to be minus u in this case. All right, whatever that you get, we add the constant of integration. So that was the idea. But remember, u is something that we introduced. We said u from this part that I erased there. It was u, which was equal to 3 minus what? 2x. So the answer now, we are supposed to bring it back, that u. We are supposed to bring back our x. So this is the same as we've got minus a half, the tan of u in this case, which is the tan of u, our u, which is 3 minus x, 3 minus 2x, like this. Minus u, our u in this case, which is what? 3 minus 2x. All right, so this is what you're supposed to have, plus the constant of integration. So this here, yes, you can separate, or you can even leave it like that as it is here, or you can separate. You can expand by this because the minus half is out of the bracket, so it expands inside of the bracket. Minus half multiplies the first term, so it's going to be minus half tan. So this is tan of 3 minus 2x. Then we've got minus half times a minus there. So minus minus is a positive. So that will be positive half into the bracket of 3 minus 2x, like that, plus constant of integration. So we can even leave it like that, or you can write it like this in this manner. It means we have integrated in simplest form, or you've written our answer in simplest form. So these are the typical questions that you must expect. You are supposed to expect such typical questions. The format, I'm worried about the format of the question. The rest you're going to figure out on that question, but the format, because these guys, they do repeat, all right? Our department, it does repeat. They do repeat a format, these questions. The next time is going to be the integral. Here you'll be seeing this as cos to the exponent of 5x, sine to the exponent of 3x. If you check question papers, you'll see a question like this. It's a repetition that is now happening. They're just changing. All right, here there is the square root of x here. They change next time. They just put this as 3, or this as 3, or as 3x as just 3x. All right, here it's 2 pi. They just maybe put as x here. They remove this 2 pi. Here it's minus 2. Maybe next time it's going to be 3x minus 3 minus 3x. You just have to check about the format. How do I differentiate? How do I integrate? I mean, a certain format of this nature. How do I, once you know that, you do as much questions, you see that it's one and the same thing. So those are your typical questions for your N6. We shall see more questions to come in our revision of the question papers, so that you get rid of the exams that are ahead of time. You will be fully prepared.